Okay, so we are going to go over a couple of questions from the homework. These were big questions. We're going to look at 25 and 28. And it all revolves around what that word means right there. So we're going to graph the inverse for each relation. Notice it did not say function. We're going to graph the inverse of each relation. Okay? And then put your answers on the same graph. So imagine like we did last class when we were trying to reflect across this thing. If I'm trying to reflect across and I were to put paint right here and I folded it like a piece of paper right across, this paint would result in something like over here. This piece right here, folding across the sheet of paper, would result in something that looked like that. And you can see it looks like symmetric. And then last but not least, this piece folded across the sheet of paper would look like, let's see, it goes all the way to negative 2.55. So it's going to go to 5, negative 2.5. Like this. You with me? So the relation, when it's reflected across that line, you get this graph right here. There's arrows there because there were arrows over here. So the answer is what you see right now in green. Does this pass the vertical line test? No. But is this the answer? Yes. Because I can fail the vertical line test if I'm doing the inverse of a relation. A relation does not have to pass the vertical line test, but a function does. Okay? So this is the answer. And then let's go to 28. So the original one, I don't expect you to know this yet because you're learning it this year. The original one was an x squared kind of graph. You with me? And the inverse, so what's the inverse of addition? Subtraction. Because they cancel to what? 0. What's the inverse of multiplication? Division. Because they cancel to what? 1. Right? What's the inverse of squaring a number? Square rooting a number. Because they cancel to 1. You with me? So here, this is a type of square root function, but we were calling it a relation that we allow it to fail the vertical line test. Okay? Let's go to number 28. Number 28, again, I don't expect you to know this graph by name yet because you're learning it this year. So this is a square root graph. And a square root graph, what's the inverse of square rooting a number? Square it. And if I put this into my calculator, this pops up. Okay? And I want you to draw the whole thing, not just half of it. If you drew half of it, I won't count it wrong. I won't. Because we learned that it's just reflecting across y equals x. But if you drew the whole thing, that's even more correct. Because these are inverses of one another. Okay? Can y'all tell me why? I'm curious. If this is x squared, think of it conceptually. And this is square root of x, which are inverses of one another. Why, when I put square root of x in the calculator, you don't see them graphing the bottom? Don't answer this, Thomas. But why does it not show the bottom? Say again. Don't be shy. Why doesn't it show the bottom? Can't be negative. You can't take the square root of something and get a negative number. Nice, Santiago. That's why, because there's a limit to that range and domain. Questions? Okay. How about from the front? Do you have a question from the front? Even here. So 26. If you guys want a little bit of help as far as to get them quickly, is this is negative 1, 1. But anyway, this is negative 1, 1. So if I flip-flop it, it would go to what? 1, negative 1. So 1, negative 1 is here. Let's pick another point. Like negative 2, 5 is close. I mean, it's almost there. So what will I graph? 5, negative 2. So this graph, when I reflect it, is going to look like that. Think of that line, y equals x, and we're reflecting it on it. You see how I'm doing that just with test points? So if this is the line that I'm trying to fold it over, it would fold over right on top of itself. Okay, so now let's concentrate on this bottom piece right here. Okay, I could do 1, negative 1, which is going to change to what? Negative 1, 1. So that will pop up over here. Let's do it in a different color. You see what I'm doing, guys? And then you could do 2, negative 5, which would go to what? Negative 5, 2. So this would look like that. So my answer is that. You just grab little points, flip them, and see where they're going to go. Okay? Any other questions? Number 10, yes. Another thing, guys, is you know that I have not yet called anyone out as far as having a phone out. And I'm okay with you having a phone out. I'm okay. You're young adults, you can manage your own phone. Please, you don't have to ask for permission to go to the bathroom again as well. I think what I'm going to do is I'm going to steal an idea that this other teacher had. It's like she has lights on the wall. Those lights that you can press in and they'll turn on. And there'll be a man and a woman. And what I want you to do is just click on it when you leave. So that I can see visually one person is at the bathroom. You see what I'm saying? Because when we're in groups and everything, I want to be able to know. And only one person go at a time and you should be good. But you don't have to ask. Alright, what's the question? 10? Alright, here we go. Let's make this one our last one. We're going to flip the x and y. And we're going to solve for the new y. Okay? What do I do first? Subtract by 8. Yeah, you don't have to raise your hand. Just say it out loud. What? Be careful. Try to go for what I want you to say. What would you do next to get y by itself? Multiply by 2 over 1. When you do that, this cancels to a form of 1. So it's gone. When you distribute, you could get 2x minus 16, or you could just leave it like this. Remember, I told you, I'm okay with you leaving it like this. Do I have to change this y to this notation, yes or no? No, because they didn't give it to me as f of x.
Is it 2x minus 16 or plus 16?
Minus 16. So let's come over here. PEMDAS order, my shortcut that I showed you, which will happen and work 95% of the time, it's worth learning, is PEMDAS, normal order. If I was sitting at x, what would normally just happen to me? Multiply by 1/2, right? First step. What would then happen to me? Because now I'm a little bit more than just x. What would be done to me next? You would add 8. So those of you who struggle with this, when these get more difficult, which they will, I could just take an x, and then I'm going to go backwards opposite. So I'm not going to add 8, I'm going to do what? Subtract 8. Now this is my bigger piece. When you use my shortcut, guys, you have to think parentheses. I got to build these parentheses because this is my bigger piece. And instead of now multiplying by 1/2, what am I going to do? Multiply by 2 over 1. Or divide by 1/2. Think about this. Which one sounds more difficult? Dividing by 1/2 or multiplying by 2 over 1? Dividing by 1/2 should sound more difficult to you. Okay? So multiplying by 2 over 1, it's still the inverse. We good? Okay. So let's go ahead and put completion grade on that right now. If you need a red pen, just raise your hand. Alright, here we go. The key